My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So if you have been watching my videos, you should consider liking to them. You can subscribe to the channel, and if you think these videos are going to be helpful uh, to your colleagues, to your classmates, you can consider sharing it with them. In this particular video, we are going to look into what is a chroot Linux construct and how we can actually uh, use this to limit a process's view of the system. I'm going to explain that in more detail in a bit, but this video is actually part of this playlist that I've been making on how do containers actually work. So in one of the previous videos, we have seen the concept of Linux namespaces, right? So Linux namespaces can actually be used to isolate a process, right, from rest of the system. So if I try to let's say explain that. So let's say uh, this is your entire system, right? And now there are chances that you want to run a process in your system, in your host, so that it cannot actually interfere with rest of the system, right? So for example, let's say you want to run a process that cannot actually interact with the host machine's processes, right? So for example, let's say you want to run an application, right? App one, and you want to make sure that this app one is actually not able to interfere with the host machine's processes, right? So this can be achieved using Linux namespaces. I just wanted to set some background, and we have discussed about Linux namespaces in one of the previous videos. So what we do is we create a new namespace of process ID, right? And we then run this application in that newly created PID namespace or process ID namespace. And once this particular application is running in a new process ID namespace, this particular application will not be able to do anything with host machines processes, right? So for example, let's say if I create a process ID namespace, this is how visually it's going to look like, right? So for example, app one is going to run inside, let's say, this PID, right? And it will not actually be able to do anything with root machines PID, right? And this is a way to isolate some running processes from rest of the machines. And there are some other Linux namespaces that can be used to isolate some other things. So for example, by using PID, we isolated processes, right? There are some other thing, for example, network namespace, right? So for example, let's say if you want app one to have entirely different network identity, route tables and everything, and you want to run app one in such a way that it cannot actually change network related things with the host, you will have to run app one in new network namespace as well, right? So for example, let's say if you create another let's say network namespace, and you run app one inside that network namespace and process ID namespace, in that case this particular application will not be able to change anything related to processes or networks of the host machine, right? And this is the way that can be used to actually isolate your process from rest of the machine. And this is what is used when we try to run containers, right? Because containers cannot actually change the configuration, change the things that is there in the host machine, right? So the very first thing that we wanted to discuss about was Linux namespaces. In this particular video, we are going to actually look into the another construct that can be used to actually achieve the same behavior that we get when we run containers, right? So if we take this particular scenario, even if we are running this application in new namespaces, let's say, right? But this particular process would have visibility to the entire system, right? So for example, let's say we have everything in Linux is a file, and let's say we have every single piece of thing beside this particular directory, that is root directory, right? And if we are running a container, we want this container to only have access to a certain set of, let's say directory, right, or certain set of files. So in other words, what we are trying to say is we are trying to limit the visibility of host machine's file system for this particular application, right? Or in other words, we want to make sure that this particular application doesn't have full access of the file system in on the host machine, right? And to facilitate that this is another construct, Linux chroot, that can be used, right? So again, for example, let's say this is your entire Linux machine, right? And you have these many directories, for example, slash root and slash bin slash home slash something, right? And you want this application to only have access to this particular directory, let's assume, right? And this is how chroot can be used. This is where chroot comes into picture, right? So apart from running that application into separate namespaces, what we would do is we would actually specify the root directory for this particular application, right? So if we run application 1 in a different namespace than the host, and we specify the chroot to limit it to this particular directory, in that case we can actually imitate how containers work, right? Because now this app one will not be able to access the other directories that we have or other file system that we have on our host machine, and it will actually be isolated from rest of the system by the help of Linux namespaces, right? So this is the part that we are going to look into in today's videos, right? So I hope that makes sense. Let's just go ahead and try to look into the demo now. So let's say this is the process that I want to run, right? This program or process just wants to access colors.md file that is located at this particular location, right? And the path where this is the path where that particular binary is available, right? This particular program. Now if I just run that, we can see that the program is actually able to access this file, right? Because the program has access to entire file system now, and we can see the file is available at this particular location. Now if I use chroot to actually limit this processes, when I see this processes, I actually mean this main program. When if I use chroot to limit visibility of file system for this particular process to, let's say, the current directory, right? So in this current directory, we don't actually have any file named colors.md, and if I use chroot to limit the visibility for this particular process just to this particular directory, this process, this executable should not be able to access this file, right? And that is what we are going to look into, right? So we are going to say chroot, and it simply takes a parameter that we want to make the root, right, for this particular application. So as we looked into this particular diagram, so this is the directory, right, that we want to make the root for this particular application, or in our case main application, right? So we are going to say chroot dot slash simply means, let's say, this directory, and then run main application, right? So it simply means run main application considering the root for this particular application or program, this directory, right? And if I run this, we should not be able to access the colors.md file, right? Because if we go back to this diagram once again, so for example, let's say our colors.md is present somewhere here, right? And since we have limited the visibility for this particular process or main process cannot access the file system or files that are outside of this root, right? And this is how chroot actually helps us to limit the visibility of the file system, right? Now if we just go ahead and try to, let's say run another program, right? So we are limiting the file system visibility to the current directory, and let's say we want to run uh, bash, right? And it simply says that we cannot run bash because we don't have anything named bash in this particular directory, right? So one thing that we should have clear as of now is, once we define chroot or new root directory for the process, this is where everything is going to be searched for, right? So if we provide any process, any command, this is the directory where we are going to search for that particular process, right? And since main was available there, we were able to run main program, right? Now, so for example, let's say we run if we try to compare this with the containers, we can run anything in the container, right? So for example, we can run all of the, let's say, basic Linux commands, right? And the reason is, the directory that we use there is the directory that by default contains all those utilities, right? All those, let's say, uh, all those interpreters and device drivers and things like that. In other words, when we try to run a container, we will have to have a file system or this directory, right, that has the things that are required to run my application. So for example, let's say if I want to run, if I wanted to run bash here, right, and this directory that doesn't have bash, in that case my application is not going to run, right? So that is why we will have to have a very minimal directory structure, I would say, right? That is going to have all the details, all the files that are required to run your program. And that is where the base image or uh, base file system comes into picture, right? So for example, when we create any docker file, we mention from, right? And that is nothing but in other words, we can say just a file system, like we mentioned here, right? So that is the file system that is used to run your programs, and that is why we use or mention or specify from in the Docker files. So I think this is the reason to specify the directory, the chroot for your container, right? So now that we have a pretty good understanding of why do we actually use chroot, let's just go ahead and try to have a look into another demo. So this is a directory that I have downloaded. I'll obviously link it to the description, and this is the blog. This is everything that I'm talking about is almost from this particular blog post. So this guy has a very minimal, I would say, a root file system, and we just have downloaded this root file system, right? And if I try to list everything from root fs directory, we can see this is a very typical, I would say, Linux file system, right? And we just have that inside directory root fs, right? And if I excuse me, if I run chroot once again, right, and we are specifying the root directory to be rootfs, and if I now say bin bash, we are able to get bash, right? But now this bash cannot access anything that is outside of this particular directory, right? That is the main purpose of chroot, right? And for example, let's say if I so for example, in, let's say, if I create a file here, and I try to access that file, we are not able to access that, right? Because we don't have visibility to the files that are outside of this particular directory, right? So another thing that I would want to discuss here is, now that we have a clear understanding of how we can use chroot to actually limit a process's view of the system, right? That would be the correct sentence, I think. A process's view of the system. So now this process's view of the system is limited to this particular directory. Now another thing that I wanted to show you is, if I run a command on let's say host machine, right? So on terminal 2 I have host machine, and on terminal 1 we have another process running with limited access to this particular directory. If I run a command here, let's say top, right? And if I try to list all the commands in this particular bash here, so we can see this particular process being run, right? And now if I just try to go ahead and try to kill that, we are actually able to kill the process that is running in the host machine from inside this shell that was spun up, specifying the new rootfs, right? But we cannot actually do that when we are in containers, right? So we have not actually isolated this particular bash. We are just specified the root file system for bash that we ran here, right? So this command, for this command we have just specified the root file system, but we have not specified, we have not isolated this bash from host, so that it cannot actually it should not be able to kill the processes that are running in the host machine, right? And to do that, what we are going to do is, we are actually going to create this or run this bash in new process ID, right? And to do that, what we can do is, we can use unshare command again. I have discussed about unshare in one of my previous videos, so maybe you would like to look into that as well. So unshare, and to run to create a new process ID, this is the way, I think. So this is how we can create a new process ID. And the flags that are being used here, hyphen fork and mount proc, are detailed in very great detail somewhere here, I think. So this is fork, and we have mount proc as well. So if you get some time, I would highly recommend checking this out. So what I would do now is, unshare hyphen p, because I want to create PID namespace, hyphen f for fork, and hyphen mount proc, and I'm going to specify the mount point to be pwd slash the process file system that we have in rootfs, right? So let's just go ahead and try to look into that. Yeah, this is the proc, right? And again, this particular command is available at on this particular blog post as well. So yeah, if you want to, I'll link this blog post in the description, so if you want to check that out. So sudo unshare, and then what I would say is rootfs and proc, right? Now if I run, let's say top here again, and if I try to kill top, we should not be able to, and we can see that top process on the host machine is still running, right? So now what we have done is, let me quickly go ahead and try to visualize that for you. So let's say this is our machine, right? And we are running bash in let's say new process id, right? So this is new process id that we have created, process id namespace, I would say, process ID namespace, and once this bash is running in new process ID namespace, it cannot actually kill the processes that are running in the host machine, because they are in different PID namespace, right? And we have limited the view of file system for this particular process, right? So let's say using chroot, we were able to limit the file system view for this particular process, right? And using those two things, we were actually able to isolate this bash application. When I say isolate, just process isolation, right? There are other types of isolation as well, and while running containers, we will have to keep all of them in mind. For example, as I said, mount namespace, network namespace, and things like that, right? And using chroot and Linux namespaces, we were actually able to isolate as well as limit this processes view of the file system, right? Host file system. And yeah, I mean, this is pretty much it about what I wanted to discuss about in this particular video. And these two constructs are actually used to run containers on your machine. And I think when we look into the Docker file, the very first line that we use from and then some base image, I think that is also pretty clear now. And yeah, if you have any question, you can comment about them. We can discuss about them in the comment section. You can consider following me on Twitter. And yeah, if you think this is going to be helpful for someone, you should share it, and you can consider liking and subscribing. Thank you so much.